Howdy everyone. In today's video, we'll be taking a look at MRP calculations. So the slide here shows a typical product review which we have learned in the previous video. And you look at the top level assembly, which is assembly A. It has a basic MRP record associated with it. The MRP record has components like gross requirements, scheduled receipts, and so on, all the way to plan order releases. And similarly, each and every subassembly or each and every part within your BOM will have a basic MRP record associated with it. We will learn more about what each of these terms within the MRP record mean and how it's calculated. But for a general overview, the gross requirement acts like the demand or what is required of each component on a week by week basis, and the planned order release is like an output, which is the amount of products that's ordered each week to satisfy the gross requirement. So in that sense, gross requirement acts like an input to your MRP, and the planned order receipt and the planned order release acts like an output, which is calculated based on what demand we have, which is the input or the gross requirement we have. So all the other values in between the gross requirements and the scheduled receipt are calculations which we will be doing. So when it comes to drafting the MRP, it's a top-down approach. So coming back to this BOM over here on the left, first we calculate what is the MRP for the entire assembly A. So let's say we need 5 units of assembly A. To now manufacture 5 units of assembly A, we might require 10 units of subassembly B and 20 units of part C. So only if we know how many units of assembly A we will need, will we know how many units of subassembly B and how many units of part C we will need. So first, the MRP or the material requirement for A is defined, which then defines the material requirements for B and C. And once the material requirement for B is defined, we can then define the number of quantity or the material requirements for D, E, and F. And once this is defined, we can then define the material requirements for G and C. So in this manner, the MRP is calculated in a top-down fashion, where we first calculate what is the requirement for the entire assembly A. Based on that number, we go all the way down and go all the way to the root cause or the bottom level of this entire MRP chain and calculate what is the required number of parts C to get the number of assemblies of A that we need. So only if we know what we have on the top will we be able to calculate all the values that go down this entire MRP flowchart. So MRP is a top-down process, and we first calculate what is required for the assembly A, then we calculate what is required for B and C, then we calculate the MRP for D, E, and F, and finally we calculate the requirements, the material requirement plan for G and C. So now let's take a look at what are all the basic inputs and outputs in an MRP system. And to do so, let's consider the MRP for one particular part, which is the frame. Its lead time is 2 weeks. The lot size is 100, which means that we have to place orders of frame in batches of 100. And the part number for the frame is 300. So first, the gross requirements, it acts like our demands. It tells that we need 150 units at the end of week 1. We need 0 units at the end of week 2, 0 units at the end of week 3, and 300 units at the end of week 4 to achieve whatever the MPS or master schedule that we have. So gross requirements acts like the demand that we are trying to meet and tells us what are the number of units we need to have at the end of each week so that we satisfy our schedule. So gross requirement is an input that goes into the MRP. And the main output of the MRP is the planned order release, which basically tells us when we place the order for the components so that we achieve our gross requirements. So according to this example over here, if we place an order of 200 units at week 2, then we'll be able to satisfy our gross requirements of 150 in week 1, 0 in week 2, 0 in week 3, and 300 in week 4. With respect to how we got these numbers and how we told that if we order 200 in week 2, we'll be able to satisfy the gross requirements, we'll take a deeper look into those calculations in the next slide. But right now, we need to understand that plan order release is basically telling when we need to place the order for the components and how much so that we satisfy our gross requirements. Similarly, we have the plan order receipt, which tells us once we place the planned order on week 2, when does it arrive? So here the frame has a lead time of 2 weeks. So if we place 200 units of order in week 2, we will be receiving it after 2 weeks, which is in week 4. The net requirements is very similar to the planned order receipt. It again tells us how many units we require at the end of each week to satisfy our gross requirements. So if you look at the the gross requirements itself, it talks about the need. We need 150 units in week 1, 0 units in week 2, 0 units in week 3, and 300 units in week 4. That's it. It does not take into account the current inventory. It doesn't take into account the scheduled receipts or anything else. So what the net requirements does is it takes the inventory and all the other stock from the warehouse into account, and then it tells us that we don't need to have any products with us for the first 3 weeks because we already have inventory to satisfy the demand for the first 3 weeks. The only requirement is that at week 4, we need to have 150 units of product so that we satisfy the gross requirement. The reason why the net requirement is different from the planned order receipt is that the net requirement does not take into account lot sizes. So in theory, we only need 150 units of product to satisfy the gross requirements. But since the lot size is 100, the planned order receipt has a number of 200. So we need to order in quantities of 100, 200, 300, multiples of 100 and so on. So our planned order release is for 200 units. So we receive 200 units in week 4, though we need only 150 units. So the planned order release and the planned order receipt already take into account the lot sizes in the MRP calculation. Next, we have the projected available, which tells us what is the number of components left at the end of each week after satisfying the demand. So it's more like the inventory in the MPS system, and it tells us that in week 1, after we satisfy the gross requirements of 150 units, we are still left with 50 units in stock. Similarly, in week 2, after we satisfy the demand for 0 units, we are left with 150 units in stock. And similarly, if you go all the way down to week 4, you can see that the planned order received was 200 units, but what we actually needed was only 150 units. So we ordered 50 units more than what is actually required for week 4. So that obviously means that we have 50 units in inventory or in stock after satisfying the demand for week 4. So that is what the projected available is. It's more like the inventory in the MRP system. And finally, we have the scheduled receipts, which tells us what is the number of parts coming in at a particular week. But this is not something that we plan, but it is something that has already occurred or an order that has already been placed in the past. So according to this example, 100 units of frames arrive at the end of week 2. And this is not a planned order release because it is not an order that we made, but it's an order that was already made in the past and it's arriving at our particular period, that is in week 2. So scheduled receipts is very similar to planned order receipt, but planned order receipt is the release that we make after calculating the gross requirements and what should be the demand and what should be the number of products ordered to satisfy the demand. whereas scheduled receipts talks about parts that have already been ordered and which are going to arrive at any of these weeks within our entire time frame. So planned order release is something that we plan for an order, but scheduled receipts is something that calculates how many parts are coming in based on a previous order. So in the next slide, we'll take a look at how we got each of these individual numbers, and if we have to draft our MRP for any particular system from scratch, how do we do so? So we'll take a look at that in the next slide. So when it comes to the information in the MRP, the information first in the red over here regarding the part name, the part number, the lot size, the lead time are all inputs that come from the BOM. Similarly, this projected available, which is 200, this arrow should point here. This 200 tells us what the current inventory is in real time, and this can change as we go from week to week. And this tells us what inventory we have in hand at any given point of time. And this is information that comes from the shop floor or the warehouse. Next, the gross requirements are connected to the parent floor. And this is a concept that we briefly touched upon in slide number 2, where let's say the frame has a parent node or it has some other part. For example, the top is the subassembly and under top frame is one of the parts. And let's say we need 5 units of top in week 1, 10 units of top in week 2, 0 units of top in week 3, and 20 units of the top in week 4. And let's say again to manufacture one top, we require 2 frames. Then we require 10 units of frame in week 1, 20 units of frame in week 2, 0 units of frame in week 3, and 40 units of frame in week 4. So this is the demand or the net or the gross requirement for the frame at each week, and this is calculated based on the requirement from its parent floor, which is the top. So this is just a simple example, but the gross requirement for each individual part or individual subassembly in the MRP system is tied up to the requirements of the parent floor based on which it is built off. So that is a key concept governing the gross requirements in the MRP. And to summarize, the plan order receipt and the plan order release, which is the last 2 rows in the MRP table, are the outputs of the MRP, and the rest of the values in the table from the gross requirements to the net requirements are just values that we use for calculating the planned order release and the planned order receipt. So these two are the decisions that come out of the MRP, and the remaining numbers on the first 4 rows are just calculations to calculate the planned order release and the planned order receipt. So we'll learn more about these calculations as we move forward. So now let's take a look at the MRP calculation for this example. And the gross requirements and the scheduled receipts are the inputs. So we already know that for week 1 we need 150 units, for week 2 we need 0 units, for week 3 we need 0 units, and for week 4 we need 300 units. So this is an input. And similarly, the scheduled receipts are also an input that tell us that based on a previous order that we have made in the past, we are expected to receive 100 units of product in week 2. So these two are the inputs coming into the MRP. And next, let's look at how we calculate the remaining values. So we already have 200 units in inventory before we go into each of these particular weeks. And in week 1, the gross requirement is 150 units. So we already have 200 units in inventory before week 1. So our net requirement in week 1 is 0 because we already have the 200. So our net requirement is 0 units. Let me just change my pointer. Yeah. So our net requirement is 0 units, and hence we need to receive 0 units in week 1. And after this transaction is done, at the end of week 1, we still have 200 minus 150, which is 50 units in inventory left with us. So these values in the parentheses of 1, 2, and 3 show the order of calculations basically. So to summarize, we already have 200 units before week 1. We need 150 units, which is the gross requirements for week 1. Since our inventory is more than the gross requirements, the net requirements for week 1 is 0 units because we don't need any additional units. We can just satisfy whatever gross requirements we have with the inventory alone. So the net requirements become 0 units. And to satisfy the 0 units net in requirement, we need 0 units of planned order receipts because we don't need to order anything to satisfy the 0 net requirement. And after this transaction is done, we are still left with 200 minus 150, which is 50 units in inventory. Now, when it comes to week 2, we start week 2 with 50 units of inventory already in the bank. So for week 2, the demand is 0 units. So our net requirements is 0 units. So if we want 0 units as a net requirement, we plan to receive 0 units because we don't need to receive any new number of products to satisfy our net requirement of 0 units. And we already started week 2 with 50 units in inventory. But look at the scheduled receipts. We are receiving 100 units in inventory in week 2. So at the end of week 2, we are left with 100 units of inventory from the scheduled receipts plus 50 units of unused inventory from the previous week. So in total, we have 150 units of inventory at the end of week 2. So similarly, we perform the calculation for week 3, and let's dive into the calculation for week 4. So at the end of week 3, we are left with 150 units of inventory. And for week 4, it states that the gross requirement is 300 units. But we only have 150 units of inventory at the end of week 3. So we require 150 units more for week 4. So our net requirement for week 4 that we need in addition to the inventory is 150 units. Because we already have 150 units in inventory from the end of previous week. And our demand for week 4 is 300 units. So we require an additional 150 units to satisfy this demand. So the net requirements become 150 units. And the planned order receipt is the number of products that we plan to receive to satisfy this net requirement. Ideally, we will plan to receive only 150 units to satisfy this requirement. But if you look here, the lot size that we have is 100. So we cannot order 100 or 150 units. We can order minimum 200 units to satisfy this net requirement constraint. So even though we require only 150 units as net requirements, we plan to receive 200 units only because of our lot size constraint. And at the end of this transaction, we are left with 200 minus 150, which is 50 units of inventory at the end of week 4. So that shows how we calculate the projected available capacity, which is the inventory and the net requirements and the planned order receipt based on the gross and scheduled receipts. And finally, the last row of this table tells us when we need to place the order to receive the planned order receipt. And if you look at it, we are not ordering, or we don't plan to receive any additional units in week 1, 2, and 3, but we plan to receive 200 additional units of product in week 4. And since the lead time is 2 weeks, if we need 200 units in week 4, we should place this order for 200 units 2 weeks in advance because of this lead time constraint, and we need to order this 200 units in week 2 itself. Only then we'll be ready with 200 units in week 4, and we won't have any delay in our production. So this shows that, so overall we've taken a look at how for an input gross requirement and scheduled receipt data, we calculate the projected available capacity, which is the inventory, the net requirements, the planned order received and the planned order received release uh, for a particular part in our MRP system, which is the frame. Yeah, so let's take a look at this MRP example. So we are making the MRP for a gearbox component, and the lead time is 1 week, the lot size is 40 units, and the part number is G321. The inputs to the MRP are the gross requirements and the scheduled receipts, which are already given to us. And now we are asked to make the MRP. So let's start for week 1. For week 1, the gross requirement is 30 units, but we already have 45 units in inventory before week 1. So since our inventory is more than the gross requirement, our net requirements become 0 units, and hence we need to receive 0 units for week 1. And after we satisfy the 30 unit demand for week 1, we are still left with 45 minus 30, which is 15 units in inventory at the end of week 1. So we went like this. And similarly, before we started week 2, we have 15 units in inventory. We are already receiving 40 units in additional inventory for week 2. So in week 2, we have 55 units of inventory now. But the gross requirement is 75 units. So we need 20 units more. So our net requirement becomes 20 units. So how many units should we receive to satisfy the net requirement? It is 20 units. But our lot size is 40 units. So we cannot just receive 20 units, but we need to receive at least 40 units to satisfy this requirement of net requirement of 20 units. And at the end of week 2, after we receive 40 units for a requirement of 20 units, we are left with 20 units in inventory. So at the end of week 2, our inventory is 20 units. So similarly, in week 3, our gross requirement is 40 units, and we already have 20 units in inventory with us. So our net requirement becomes 20 units again. We again cannot place an order for 20 units, so our minimum lot size is 40 units, so we place an order for 40 units. And after week 3, the transaction is completed, we are again left with 20 units in inventory because we plan to receive 40 units, but we are only using 20 units of those. And finally, for week 4, we require only 15 units. But at the end of week 3, we already have 20 units in inventory. So our net requirement is 0 because our inventory before week 4 is more than the gross requirement itself. So our net requirement is 0. The planned order received to satisfy this net requirement should be 0 because we don't need to receive any additional parts to satisfy this 0 net requirement. And at the end of week 4, we have 5 units left in inventory because we require 15 units, but we already had 20 units in inventory with us. So we are left with 5 units in inventory. So to complete the table, we need to add in data as to when we are going to place the order for our receipts over here. So this is 0. Just here. So in week 2, we plan to receive 40 units of product and the lead time is 1 week. So we need to place an order for 40 units in week 1 itself so that we can receive 40 units in week 2. And similarly, in week 3, we again plan to receive 40 units in product. So to satisfy this received demand, we have to place the order 1 week in advance, which is in week 2 itself. So that after 1 week, week 2, the order placed in week 2 arrives in the form of a planned order received. And for week 3, we don't need to order anything. And for week 4, similarly, we don't need to order anything. So now let's take a look at how MRP records are linked. So consider the main assembly A over here. So this is the MRP for the main assembly A. And We have calculated the MRP already based on the previous method that we discussed, and the planned order release or the POR is the main output we have calculated for A based on this MRP. So now how do we calculate the MRP for B and C based on the MRP of A? And that is called MRP linking, and the planned order release or the POR of A directly translates into what will be the gross requirements of B and C. So for example, now let's consider the MRP of B. The planned order release for A in week 1 is 0 units. So the gross requirements for product B in week 1 is 0 units. The planned order release for product A in week 2 is 60 units. And to manufacture 1 unit of product A, they require 2 units of product B, because you can see this 2 over here. So it's in a 1:2 ratio. So if you need 60 units of product A to be released in week 2, then we should have 120 units of product B ready in week 2. So our gross requirements for product B in week 2 is 120 units. Similarly, for week 3, it is 55 into 2, 110 units, and so on. So the planned order release for for the previous component or the parent component in the MRP records multiplied by the quantities required per of the child component to manufacture one of these parent components gives the gross requirement for this child component in the MRP system. So yeah, again, to recap, we require 0 units of planned order release of product A in week 1. So the gross requirements for product B in week 1 is 0 units. In week 2, we plan to release 60 units of product A. But if we want to release 60 units of product A, we should already have product B ready with us, because product A depends upon product B. So this translates into requirements or gross requirements for product B, which tells that if we want to release 60 units of product A in week 2, we should already have 120 units of product B ready in week 2 in the form of gross requirements to satisfy this POR. And similarly, for week 3, we've calculated the gross requirements of product B and so on. So now that we know the gross requirements for product B, we can go ahead and calculate the POR for product B based on the method that we discussed. And once we have the POR for product B, then we can go ahead and feed this information to calculate the MRP table for products D or sub-assemblies D, E, and F, after which we can feed that data to draft the MRP for parts G and C. So when it comes to product C, if you look over here, it comes in 2 instances. One under the main assembly A and under sub-assembly F. So to calculate the MRP for the part C, the MRP for part C not only depends upon the POR of A, but it also depends upon the POR of F. And once we combine these 2 PORs and add the gross requirements for A and F on a week-by-week basis, we can then calculate what will be the gross requirement for the product C. So in essence, the product C depends upon the main assembly A and the sub-assembly F, and only once we calculate the POR for A and F will we be able to calculate the MRP records for product C. So coming back to the previous slide about low-level coding, which we already discussed, it also talks about the strategy about how we go about building the MRP. So over here, level 0 is the highest level, and level 3 is the lowest level, and that represents each individual level coming down this product tree of RBOM. So in level 0, we have the main assembly A. In level 1, we have a sub-assembly B and a part C. In level 2, we have a part D, a part E, and a sub-assembly F. And in level 3, which is the lowest level, we have 2 parts, G and C. And MRP must be built from a top-down level because to calculate the MRP for B, we need the POR for A. So we need to calculate the MRP for A before we can calculate the MRP for B and the MRP for C. So the MRP must be calculated at a top-down level. So to indicate the order in which we calculate the MRP, we can simply draft a table like this, telling which parts lie at which level. So for example, over here, A lies at level 0, B lies at level 1, C lies at level 1 and at level 3, but we write level 3 purely because to draft the MRP for C, we require the MRP for F. So the MRP for C can only be calculated at level 3 and not at level 1. So we write 3 as our lowest level code for C. And similarly, D, E and F lie at level 2 and G and C lie at level 3. So we first calculate the MRP for A, then we calculate the MRP for whatever is there at the next level, which is level 1, which is only B. So then we do B. After we do B, we can now do the MRP for components at level 2, which is D, E or F. And we can drop this MRP in any order. We can do the MRP for E first, and then we can do the MRP for D, and then the MRP for F. Or we can do the MRP for F first, and do the MRP for E next, and do the MRP for D in the end. So the order doesn't matter, but the MRP for D, E and F have to be done only after we draft the MRP for B. So once we finish the MRP for D, E and F, we can finally go to level 3 and then we can calculate the MRP for G and C at any particular order. So the order of making the MRP is A first, which is level 0, then B, which is level 1, then D, E and F in any particular order, which are parts or sub-assemblies at level 2, and finally C and G, which are individual parts at level 3. Yeah, so a quick example. So over here we have the same product tree, BOM, and we have the MRP record for A over here. And based on the MRP record for A, we then calculate the MRP record for B because that's at level 1 and that's the next immediate step. And once we do the MRP for B, the next step is to do the MRP for D, E and F, which has been done over here. So we've calculated the MRP for F over here. And before we go to the MRP for G and C, we need to complete the MRP for D and D. Though it's not an absolute requirement, that's more of a standard and a standard procedure or protocol to drafting the MRP. So after we make the MRP for B, we make the MRP for F and D and E as well. And once we are done for the MRP of all the assemblies and components at this level, then we can move to the MRP for G and C. So this table over here is the MRP for component C. And the MRP for C depends upon F and it depends upon A as well. So we need to know the POR for A and the POR for F as well. So for example, for A, subassembly or main assembly A, in week 1, the POR is 0, whereas for the part F, in week 1, the POR is 160. So to manufacture 1 unit of A, we require 5 units of C, and to manufacture 1 unit of F, we require 3 units of C. So the gross requirement for C in week 1 becomes 0 times 5 plus 160, which is this number, times 3. So this is basically the POR for A, and 5 represents the number of C's to manufacture 1A, 160 is the POR for C in week 1, and 3 represents the number of Cs to manufacture 1F. So that's how we calculate the gross requirement for C in week 1. Similarly, in week 2, the gross requirement for C is 60 times 5 plus, here we have a 0, plus 0 times 3, which is 300. And similarly, in week 3, it is 55 times 5 plus 0 times 3, which is 275. And once we have these gross requirements in place, we can go ahead and calculate the output, which is the POR for C. And now a quick note. So sometimes companies try to optimize their MRP. So if you look at the MRP for B, the planned order release in week 1 is 90 units. And sometimes companies, what they do is they make the planned order release in week 1 0 units and instead add the 90 units as scheduled receipts in week 3. So they've just made or zeroed the planned order release, and this quantity of 90 units in the POR is now added in the scheduled receipts in week 3 because the lead time is 2 weeks. And this typically occurs to a POR or a planned order release only in the week 1 or the first week of your MRP, and this is a strategy which companies sometimes use to minimize loss of information. To conclude, we have seen what a BOM is and how it is used to draft an MRP, and we have also seen that BOM has what parts are required and the individual quantities of each part to manufacture X number of top level assemblies. But let's say the cost associated with each part or each sub-assembly is also an input to a BOM. So to manufacture one top level assembly, knowing the individual costs or prices of each sub-assembly or sub-part within the top level assembly will tell us what is the cost to manufacture one top level assembly. So that is another alternative use of a BOM, which is cost estimation. And when it comes to the MRP, what we have been seeing so far is an idealistic scenario. But the inventory levels, the lead times, the delivery times, and all these factors which affect your MRP can continuously change on a day-by-day basis. For example, let's say we are having an MRP for different parts for, again, a car manufacturing company. And let's say that the lead times for the tires to get manufactured and shipped to us is 2 weeks. But now imagine that a storm hits the road, and because of that, the lead time has been shifted to 4 weeks because of the storm and difficulty in transportation. So the lead time has been increased, and the MRP must constantly be updating itself on a real-time basis to show this increase in the lead time. And so that boils down to this point which I'm trying to highlight, which is that lead times are very rarely constant, but they vary on maybe not a day-by-day basis, but definitely a month-by-month or a year-on-year basis, depending upon the weather conditions or depending upon the manufacturing capacity or the manufacturing speed and so on. And the other important aspect that we have seen so far is the product 3 BOM is like has several levels to it. We have seen that even for a simple assembly where we needed to manufacture a table, we had 4 levels, and it became quite clumsy, or it became quite complicated to draft this BOM just for a simple table which had around 8 parts. So once again, when we start drafting BOMs for sub-assemblies and main assemblies which have thousands of parts, we need a better system to do so. And that is where cellular and continuous flow manufacturing trends come in. And by using this concept of cellular manufacturing, we can get a more flatter BOM. So what that means is that the levels in the BOM will be much lesser than what we have seen now. So it will not have so many levels and so much indentation like what we have seen in the product 3 BOM, but it will be rather a more flatter BOM, which will help us to simplify its understanding. And that's where the concept of lean manufacturing also steps in. So this is where we are going to focus our attention as we move along this course. But yeah, that's about it for this lecture. Thank you.